delighted to actually have our keynote for this event of Fast Data than Vinny. So I want you to join me, put your hands together for Vinny.
So I'll give you guys a quick overview of what I'm going to chat about today. I really want to give an overview to the audience here, and it's really difficult to speak about something like blockchain with so many people. There's like 3,000 people in the audience, and so everyone's level of understanding of what Bitcoin is and blockchain is very different. So I'm going to start with some of where how we've evolved to where we are, and then I'll get into a bit more about blockchain down the line. So, thanks for the introduction, Ron. Basically, background is, I was born and raised in South Africa. I started a search engine marketing company, 2003 in Joburg, moved to Cape Town, and then sold a stake in that, moved to Silicon Valley, and I've been there for the past decade. And while I've been there, I've done a lot of interesting things, including dealing with gift cards, digital gift cards, KYC compliance, level stuff, selling that company to First Data Corporation, the largest payments company in the world, and then got involved in Bitcoin and blockchain. So I've been in that space for about 4 or 5 years. I joined the board of the Bitcoin Foundation, which has become more of an advocacy group around Bitcoin. And I started my latest company, Civic, which is a decentralized identity platform and built on the blockchain. So what does that mean? I'll tell you in a bit. But I also have interest in South Africa. I have a company called Newtown Partners, which works with local companies and startups and international to launch ICOs, do token economy design, and that's all around the cryptocurrency world. And Multicoin Capital, which is a cryptocurrency hedge fund, looks at investing in things like Ethereum, Bitcoin, etc. So I have a diverse background. I understand the South African context reasonably well as living in Silicon Valley. So I'm happy to share some of these learnings and insights with you guys today. So when we talk about the evolution of data storage and ownership of data, we've got to start with how we got to where we are, and then I'll work into blockchain, Bitcoin, and then trust and identity. So if you remember the days of these tapes that we used to store data on, these big reels of tapes, which probably stored about 1 meg, and we moved to stiffy and floppy disks, CDs, etc., zip drives, all the way to just a RAID hardware on your desktop, and then eventually we got, there was just not enough capacity, and we all moved to the cloud. So I store something like 100 gigabytes worth of photos on Google Photos in the cloud, and I think all of us here in some way, shape, or form, on a personal level, using cloud storage, and businesses as well move to the cloud because of all the great benefits and efficiency it delivers to us. Now, what is a blockchain, and how does that tie into what data is? So when you're storing data in the cloud, and you're writing information to a private space, like your photo album, etc., that data is not shared with anybody else. And when you're doing transactions, what happens is, in the business world, you centralize these transactions. This data sits on your own server, and you know that it happened, and you can prove to yourself through internal audits that it happened, but there's no way to cross-validate to somebody else. So what that means is there's no public view of what transactions are happening in your business. The notion of a blockchain is one where you have public and private blockchains, and for the majority of my talk, I will talk about the public blockchains. But these blockchains basically sit as a network of node infrastructure that houses data. And at the moment, these blockchains can't handle 100 gigs worth of data, etc. Right now, it'll eventually get there, but it's able to validate transactions through these computers in the network, and you can be assured that a transaction happened. With running a local database, you can modify timestamps, you can change things. With a public blockchain, you can't do that. So the unique characteristics of blockchain technology is one, it's really about transparency and immutability. When you write a transaction to the blockchain, everyone can see the transaction happened, and it can never be changed because all these computers are validating each block, and each block essentially is a set of transactions. And as you add more blocks to the chain, you can't go back and edit previous ones without an immense amount of computing power, and so it becomes economically prohibitive to actually do that. And so when they say it's cryptographically secured, it means that we're using crypto algorithms, so deep mathematical algorithms to ensure that you can't just reverse engineer and guess what data is behind what is being placed on the blockchain. The decentralization aspect of it is very important. It means that no one party controls the data that's placed there after it's put there. So you can't have a situation where someone can override a transaction after it's being committed to the blockchain, which means data integrity is high. And believe it or not, it actually has some very interesting efficiency and cost reduction benefits for organizations, because if you know data can't be modified, you can trust the data. There's no need for additional auditing and processes in your organization. You know that once it's committed to the blockchain and it's there, that transaction happened, and therefore it can't be changed. One of the examples I brought up to a smaller group this morning was the notion of triple entry accounting. So many of you may or may not have heard of this, but triple entry accounting is essentially, hopefully, doing away with external auditing and accounting in the future. So today, when an auditor goes to your office to do an audit on your books, they're going to pull up invoices, they're going to phone your suppliers, your partners, to confirm a transaction actually happened. With triple entry accounting or shared accounting ledgers, that transaction would have been committed to a blockchain and would basically be verified and made immutable at that point. And so the system can be self-regulating and self-auditing, and there's no way to modify those transactions. So a little bit harder to cook the books. And these are very sort of far-out ideas for now, even within the blockchain world. But it's probably 3 to 7 years away, and it becomes very interesting how you can create this open, transparent infrastructure where, remember, it's all encrypted, so people can't see the actual data. It's more about what transactions happened, and can you validate that it happened at a point in time. So that takes us on to Bitcoin. So what is Bitcoin? Bitcoin really was the first decentralized ledger technology product out there, and the use case was to create digital money. And what Satoshi Nakamoto, and he, she, they, we're not sure who the group was, they basically wrote a white paper back in 2008, and then they published the software in 2009 to create this system where the economic incentives are aligned for everybody to ensure that data doesn't get manipulated or changed after it's been committed. And there's a process of mining where coins are received by people committing compute power to the network. And the more compute power on the network, the more it's impossible to change the data. So today, the Bitcoin network has probably more compute power than, I think, most servers in the world combined. I mean, I think at one stage, the data was, there was more power in the Bitcoin network than the top 500 supercomputers in the world combined, and that was a couple of years ago. So it's the biggest computing network on Earth right now. And the market capitalization of all Bitcoins is about $150 billion. It's a very interesting network. It does have limitations by recent changes in design to Bitcoin, but the real interesting part of how this plays out is the notion of decentralized ledger technology, so blockchain technology being applied to business and industry, means that there are many other solutions out there today that you can look at integrating. So the key problem that Bitcoin solved was the double spend problem. And this is important to understand. If you think about the late 90s and even early 2000s, before things like DRM came out, one of the biggest issues with music files is that you could copy them, right? So this is a big issue in the US, and you could send one file to 20 people, you could share it on torrent networks, etc. What Bitcoin did was, by creating a ledger technology and making sure that when one transaction happened, it couldn't be repeated, they basically created a system where you cannot copy a digital asset. So you can't send the same file in theory to two people, because once the network receives the one transaction, it validates that. Any subsequent transaction would be rejected because it's already been sent. So I can't send you $100 and you $100 and create money out of thin air on Bitcoin. That's the key thing that Bitcoin solved, which actually changed the way the world thinks about blockchain technologies. So, again, it's a very complex space, but essentially you can have double spends, but you need to have an immense amount of computing power to hijack the network in order to do that, and that's what makes the system so secure. So what can we use blockchain technology for? And there are a couple of things I've highlighted here. I think the most interesting thing is storage of digital records. So if you think about the current systems we have today in government and business, everything from birth certificates, ID documents, property, title deeds, etc. Excuse me. It's all stored in paper. And it's really easy to just, photocopy, copy, forge documents, forge ID documents, driver's license, etc. So how do you store these digital records and make sure that people don't issue a passport to somebody who just was born, yesterday, and they're not supposed to get it? So one of the biggest problems as being a South African, I've witnessed this firsthand, is 10 years ago, I could go to Europe and I could walk into Switzerland without a visa, I could go to UK without a visa, and now visas are required. And it's a big problem because they don't trust South African passports, or they didn't for a long time. They probably still don't, because I can't get in on my SA passport. But the reason is because someone at Home Affairs could basically create somebody out of nowhere and put the record on the system and say, well, he was born in this date, and he has a passport for this person, he's a South African citizen. Now, with blockchain, you can't do that. You can't go back 20 years and write a record that doesn't exist. And this is the power of what this offers us. If we can move to systems where you can store records securely over long periods of time, it becomes impossible to create fictional characters in our society. It also means that things like digital assets, you may have heard of tokens, you could do things like CryptoKitties. CryptoKitties is basically a unique digital asset on the Ethereum blockchain where you can own a unique digital kitty cat. And these things sell for like $100,000 because there's only one on this chain, and you know that no one else has a copy of it, and the ownership can move from one person to another. And so these assets are growing, and there's a standard called ERC 721, for those who are technical, which basically creates non-fungible assets. So you could take things like baseball cards and Magic the Gathering cards, etc., and these issuers can issue a limited number of digital assets which actually have value, and these assets can be exchanged for money or trading between people, but you know that the issuer can't create more than what is out there. And this is a space, by the way, you should pay attention to. I think the non-fungible tokens is going to grow massively in the next 6 to 12 months. And I'm aware of a number of projects coming out where you can actually attach records to a blockchain. So, for example, title deeds of your home, your car. Imagine being able to just, instead of in the US, there's pink slips, and there's other mechanisms. I can't remember the licenses and registration. But you can literally transfer a blockchain token to a person and transfer ownership of a vehicle across, all digitally. Which then means you can do things like smart contracts. So you could have a contract with someone, and you could say, I'm going to transfer R1 million to you for this property, and when the property title deed transfers to your holding, the money gets sent to the person in real time. And so both people can sign the contract knowing that when there's delivery, there's settlement at the same time. And so things like smart contracts are becoming very, very popular. It's still nascent. There's lots of issues to be worked out. But essentially, you can move to a world where it's effectively a trustless economy. You trust the code, and you trust the way the system is built and designed to execute contracts without having to have someone check. So anyone who's bought a house here knows it's a painful process, conveyancing, taking the bond out, etc. And you can actually just digitize that and do it within days or even hours. And this is an area of potential interest for South Africa, but there's companies like Propi in the US that are doing this already and actually executing land title trades and transactions on the blockchain, settlement in Bitcoin, etc. It's very powerful stuff. So why use smart contracts? First of all, they're secure. If the smart contract's been audited and you can trust the code behind it. It's obviously low cost. You can cut out lawyers in the process, etc. And it's fast and decentralized, which means that the decentralization part is important because it means that no one can really hijack the smart contract. It's run on a network like Ethereum where there's a ton of nodes executing the contracts. And so the consensus algorithms around these systems make it so that we can actually trust the code won't be changed. And that's an important thing because in the digital world prior to blockchain, the concern is what happens if someone goes and edits the code and says that we'll reroute the token for this property to a different address, things like that. You can't do that with blockchain because the immutability that's built into the network. So if you look at the various ways you can build on blockchain, there's identity, there's governance, financial assets, there's notary, there's n number of different ideas. And I don't have the ideas for all your businesses, but every one of your businesses out there are ways that you can use this technology to reduce costs, automate things better, make it better, cheaper, faster, improve your customer service delivery, etc., and really improve the trust within your organization. So then, trust. This is one of the things which I think is really, it's a misunderstood concept. And as you scale society, trust becomes a big issue, a big factor. There's a number that a social scientist called Dunbar came up with. It's called Dunbar's number. And he did research around what's the most number of people in society that you can really trust, right? In your social circles, in a small village, in a town. And it came up that roughly you could probably build a relationship with about 150 people where you would trust them. And the moment it goes above that, the trust starts wavering. So the important point of this is the trust doesn't scale. So you trust your family. Maybe you have 5 people in your family, your immediate family at home. You trust them with your life. And then maybe there's 15 people in your sort of cousins, this little outer circle, best friends, etc. And then, your workplace, you'll expand to 35. But when you get to 150, it kind of caps out. No matter who you are, it's just very difficult for humans to build relationships past 150 people. And so people who have thousands of Facebook friends, I guarantee you, they don't trust all of them. And so when you get to 500, 1,500, and the rest of the world, there's just no way you're going to trust anyone with a transaction at that level, especially as the value increases. So how do you fix this problem? How do you fix the problem in society where we just don't trust each other, right? Bitcoin was founded, and when they created the first Bitcoin, the Times article was actually a reference in that first Bitcoin. And it was really about how the banking sector was falling apart. This is, after the crisis of 2008. And, if you look for, it was kind of a warning of things to come in terms of trust in the world, because you look forward to 2017, you can see that Equifax had a massive hack, 143 million user records. That's a big credit bureau in the US. My information was on there. Everyone else is pretty much in the US who's economically active. Their information was leaked. And it was just a simple username and password that got the hacker in to the system. And you look at 2018 again, we've had Cambridge Analytica, we've got, and that's been with Facebook and Twitter now apparently, and these hacks are not ending. It's becoming easier and easier to hack systems that are secure by username and passwords. But the scariest part about this is our data is all centralized. So all your personal information sits on one single server. You get access to a username and password for that server, and you have access to 143 million individuals' personal information, social security numbers, home, financial records, etc. This is a big problem in society because now, if someone knows your information, they can impersonate you. They can, there's so many stories of how people's lives have been ruined by this information getting out. And so we have a right to protect our own privacy and information. And the more we see how databases are being centralized with large amounts of personal data, the more risk there is to society. So how do you commoditize trust? Because this is the real issue here. And so in society over years, and call it thousands of years, we started off with gold initially being something that you could trust because it's a physical commodity. If you held it in your hands and you gave it to someone, there's a settlement of a transaction, etc., you could trust that the gold was good. And people would accept gold universally across the world. And then, in the past couple of 100 years, we've had banks come in, and banks have basically printed paper. And so the paper, the bank notes, is essentially trusting someone. Now, you're trusting the bank, you're trusting the Reserve Bank, and 100 years ago, in fact less, 50 or 60 years ago, it was a bit of a gold standard. So the banks printed money, knowing that there was some gold in reserve in their bank that they could make sure that they could settle the dollars. And then they moved off the gold standard. So now you're basically trusting that the economy itself can continue to fulfill the promises of society by continuing to print more money, but there's no real asset or commodity backing it. And then we move into the digital commodity space, where you basically have to trust that the math that's being written behind these cryptocurrencies are rock solid and can last for centuries and not going to be, that they are immutable. And so we're moving to a different frame of reference of how we trust assets and commodities and people in society. So when we talk about identity, one of the things about identity is that it's very personal to everyone, obviously. So, but when you give it out to people, you give it to whether it's the IRS in the US or SARS, whether it's your banks, your healthcare, you're always sharing a bit about yourself. And essentially, they're taking that information and they're aggregating it into a database of all the people they deal with. And so this creates problems, especially when you're not in control of that. How do you revoke the ID information from a server that's already storing it? And the reality is you probably can't for many years to come. But there is hope around how we decentralize identity in the world and how we give people control of that. And so the good news is things like GDPR in Europe and POPI in South Africa. It's making strides towards companies being more responsible about personal data hygiene and what you're storing about your customers. When you look at the big data world, it's kind of scary how much information they can derive, or how much of your behavior they can derive from your information. So these companies are able to take millions of consumer sort of behavioral data, and based upon knowing who you are and your unique circumstances, predict what products you're going to want, what services, etc. And it all sounds great, but it's kind of creepy as well. So I think the biggest issue happens when there's a breach of trust and this information gets out. So I wanted to show you guys a quick video about how how insecure your personal information is, and this is actually it's quite an eye-opener.
So I invited a few of the world's best hackers to try to hack me and show me where my vulnerabilities are. And now I'm going to meet them in Las Vegas for DEF CON, the biggest hacker convention of the year. They're going to hack me using social engineering, which is essentially hacking without any code. They just use a phone and an internet connection.
Do you want to do a sample phishing call?
What's phishing?
Phishing is voice solicitation, and basically what you do is you use the phone to extract information or data points that can be used in a later attack.
Let's do it.
Okay.
Who are you going to call?
Maybe I'll call your cell phone provider and
Okay.
see if I can get them to give me your email address.
I bet they're good. I bet they have my back. But yeah, go for it.
I'm going to spoof from your number, so it's going to look like it's calling from you.
Okay.
Hi, I'm so sorry. Can you hear me okay? My baby, I'm sorry. my husband's like, we're about to apply for a loan and we just had a baby and he's like, get this done by today. So I'm so sorry. I can't call you back. I'm trying to log into our account for uses information and I can't remember what email address we used to log the account. The baby's crying and can you help me? Awesome.
In just 30 seconds,
At gmail.com?
Jessica gets access to my personal email address.
Now, if I needed to add our older daughter on our account so she could call in and make changes, how would I need to go about doing that? You would have to send me a secure PIN through a text message? Yeah, well, the thing is, I don't think I'll be able to receive a text message if I'm on the phone. Shh. Oh, I'm not on there either? So I thought when we got married, he added me to the account.
Jess uses my girlfriend's name and a fake social security number
5127.
to set up her own personal access to my account.
Wait, I'm sorry, so there's no password on my account right now? Can I set that up?
She even gets the support person to change my password.
Thank you so much for your help today.
So she just basically blocked me out of my own account.
I'll get her fed after this. All right, thank you.
Holy shit. So they just gave you access to my entire cell phone account.
You're gonna have to go on and change your password now because it's Jess, my name.
And all it took was a crying baby and a phone call.
Yeah.
So you'd think that doesn't really happen, right? It does. Everyone here, I think, probably is aware of some story, even in South Africa, where people have their phone numbers ported to a different provider, and then they use your SMS to break into your bank account, steal money. This happens all over the world. Mobile providers are trying to get smarter about it, but they still haven't figured it out. And this is becoming a bit of an epidemic, because the moment that hackers have access to your personal information from the credit bureau, they can phone, they can pretend to be you, they can give a lot of personal information, they can pass the KBA questions on the phone when you phone in a call center, they can get access to your money, they can transfer it out, and by the time you even know what's happened, you're out of pocket, if not more. So how do we solve these problems? I don't have the answers. I think it's more about us thinking about solving the crisis of centralization of identity. And so the one thing which is really important to understand is that we've moved from a world where it's really been about usernames and passwords to a large extent for many years. And now it's, because that obviously is insecure, when people hack a server, they get, people notoriously use the same username and password everywhere. Okay, this is a very fun fact. Some of us probably change it up, but there's probably a few places that if one place is breached, they can run a script and find the other place and log in there and hack you. So, we've moved on, especially in the financial services world, to saying, oh, well, let's ask questions, when were you born? What's your address? What's your postal address? I mean, these are silly questions. For 20 bucks, I can buy all this information about you online, on the dark web. I mean, literally, it costs $20 for a social security number on the dark web. So if someone wants to hack you and phone your bank, they can buy the information. These databases are all being sold on the dark web, and it's just impossible to shut that down. So I think it's about the way we think about security that's a problem, because what we're saying now in society is security is okay because as long as the person we're speaking to knows information about whoever they log in, it must be that person. I mean, how ridiculous is that? How ridiculous is it that we think security today means knowledge of information? So we have to move away from that. We have to move away from the presumption that knowledge of information equals identity. It does not. It cannot, especially when all your information is already probably out there. So what do we do next? How do we solve that? The answer is, we believe, to do validation and keys. So in other words, having a digital wallet on your phone, on a device, where there's cryptographic keys that cannot be recreated. You have to have physical access to the device. It's kind of like the fobs that you see from RSA, but with your personal information on it. And when you're logging into a bank account, when you're going anywhere, it has to have those private keys from that device. And those, hopefully you put a PIN code on your device, etc. So a hacker in the middle of Eastern Europe or China cannot use your information because they have to access the keys, and that requires physical access. So we have to move to that as a mechanism of protecting information. And that physical access is something which, obviously someone can come, the usual gun to your head scenario, take your phone, force you to open it, but they can do it to you anyway today in many other ways. So that's not a good enough argument for not moving in that direction. Even more so, when you look at the argument against physical containment of personal keys, which proves that you own pieces of identity, one of the biggest issues that people say is, well, again, what happens if your phone gets hacked? That's great, but only you get affected, because if your information is stored on your device, you get affected, not the other 143 million people out there. And so we got to figure out, how do we move to a point in time where if people are responsible for their own information and for some reason it gets out, it doesn't affect everybody else. So if you look at how we think, and when I say we at Civic, we think about a decentralized sort of global digital identity platform, we see that we need to basically get to the point where we can digitize and authenticate the existing offline world's documents and move that into giving consumers control of keys which prove that the information has been validated and they're the owners of the information. So the next time they log into their bank account, their website, whatever it is, if you don't have the keys, you can't get in. It's as simple as a lock on a door. And the benefits for this is that people you own your own data. You choose who to give it to. You can revoke access. You don't need SMS as a two-factor authentication. It's all key-based. When you move to the point where every single bit of personal information you have is matched to a private key which no one else can replicate unless they have the device, it changes the way you think about security, and you then can sleep better at night knowing someone's not going to hack your phone. Like I've taken SMS authentication off all my accounts. So any major account, I've moved to hardware-based authentication, whether it's YubiKeys or other keys out there. I don't use SMS. It's just not secure. And then, in terms of the central point of failure, because data is always stored on your devices, you are the central point of failure for your own information, but you don't affect everyone else, and that's important. Also, we think that moving away from OAuth. OAuth is a big issue. And so those of you who are technical, OAuth is essentially the system that powers Facebook Connect and login with Twitter and LinkedIn, etc. It means that there's always someone watching your transaction. And so in the current world we're moving into with data privacy, you don't want a situation where there's a third party monitoring everything you do just so that they can authenticate you, that you are who you say you are, but also capture your usage patterns and data as well. So moving away from OAuth to more of a two-party system where I give you my keys, you can validate that independently, and only the two of us know that a transaction happened. That's how privacy gets to move forward. It should be between the consumer and the end user. An example I'd use, and I bank with Investec and I rent cars with Avis. If Investec wants to offer a special rate on Avis, and I want to go rent a car from them, Avis should be able to accept credentials from me which prove that I'm an Investec customer without giving them my bank account number or anything else, and be able to rent me a car at a discount because of that. So we need to move to a world where we can enable this sort of privacy, where people who are using the identity can use it without having to divulge information about themselves. Another good example, which we're working on is just alcohol consumption, for example. Being able to buy a beer or any alcohol and proving you're over 21 without, and in the US it's 21 is the legal age. When you walk into a bar, having to give your driver's license to the bouncer at the door, he gets to see your address. He's probably not going to memorize it, but sometimes they have these scanners, so they're scanning to validate the ID every time you're walking in. Now there's a record of you going into that bar at a certain time. Again, in the US, this is a big issue because in the US, there's just the history of the US. User privacy is a big, big issue, and it's already become an issue in Europe with GDPR. So how do we, the only way we're going to get around this is moving to a situation where people respect data privacy, and you only take as much or as little information as you need from a customer to perform a transaction, and give people control. And if they want to give you more information, that's on them. And again, just trust, privacy, reusability. Whether Civic is the company that actually winds up building all this out in the long term, or their competitors, or whatever else, we just think that moving to decentralized digital IDs are the future of the space, and it's all enabled by blockchain because you have to have nodes which validate the information that's placed on there to enable privacy. And that's just a quick screenshot of what we do in our app. But basically, things like, for example, Fika and Rika, being able to move in, walk into a Vodacom or an MTN and be able to reuse KYC information you just use at your bank, etc. It's the dream, right? Like when I come to South Africa and I want to go get a SIM card, I mean, it's ridiculous. I want to change an address. I don't even live here anymore, and it's actually, I can't believe how problematic it is just going and getting a SIM card. Or I bought my niece I tried to get a Vodacom, an iPad with a SIM card, and I had to go through Fika and Rika, and it's just, I don't understand how the system is going to scale into the future. I mean, it's already probably 10, 15 years old. So we have to move to digital solutions. We have to be able to trust the identity information that's on your device. And so these are the things that are possible with blockchain. And the point of my talk today was, I've given you one example. This is the world I'm in with identity, but blockchain can be applied in many ways to your own businesses. And so you need to think about, how do you eliminate friction? How do you enable privacy? How do you re-enable trust between yourself, your customers, your partners? And how do you do it with using decentralized ledger technology? And if you can reimagine the way you do this, you can change the way your business functions. You can improve operating margins, operating income. You can reinvest in other areas. But you can also move yourself into the next phase of evolution. And this is where the internet, what the internet did for literally the world, I think blockchain will do for the world of trust. And that's going to be exciting. Thank you.